See, I had to do that first before I went to the full screen.
Yeah.
Now I can go to full screen. Are we happy? All right. Section 7.2. We talked a little bit about this yesterday. And we talked about end behaviors. You remember yesterday when I said that if we had an even exponent? What can you tell me, Blaze, about an even exponent? What about the end behaviors? They're both up or they're both down. All right, so if I had, for instance, 2x minus 1, we know that's linear, and we know that one end is down, one end is up. And if I had 4x squared plus 3, we know that's a parabola, both ends are up. If I put a negative there, both ends are down. So when we have even exponents, the end behaviors are both up or they're both down. Here's how we would do this. Let's take the negative 4x squared plus 3. I know that's going to be a parabola. I know it's going to open down. The y-intercept is at 3, so it'll look something like this. Describe the end behaviors. Left end falls, right end falls. That's how we say that. The left end falls and the right end falls. If we had an x cubed, what type of shape is x cubed? S-shaped curve. It's an S-shaped curve. Okay? The left end falls, the right end rises, and that's how we say that. Even if I had something where maybe 2x to the 8th, okay? What can you tell me about the end behaviors of that? Left end rises, right end rises, okay? And so that's how we describe the end behaviors, okay? And there's a section where it says describe the end behaviors. There's no need to graph. We already know. If it is an even exponent, both end behaviors are the same. If we have an odd exponent, the end behaviors are different. Okay? By the way, if I had a negative, and I'll put this in a different color. If we had a negative x cubed, left end rises, right end falls. Okay? So you can have a section in your homework where it says describe the end behaviors of each graph. And that's what you have to do. All right? Let's take an equation. Let's take a function that looks like f of x equals x to the 4th minus 5x squared plus 3. Tell me the general shape of that. It's a W shape. Left end rises, right end rises. Okay. All right. What we want to do here is we want to find any local maximum or local minimum. So we're looking for any of the local max or the local minimum. Local max and min. So I'm going to go over to the calculator here and graph that. And Julie, you won't be able to see this graph, but put this in your calculator, which is x to the 4th minus 5x squared plus 3. And the first thing I think you should do, especially if you have one of your own calculators, is go to your zoom menu and scroll down to Z standard. And that puts your grid your x-axis goes from negative 10 to a positive 10, and from your y-axis from negative 10 to positive 10. That's a standard grid, Zoom standard. And you should be okay with everything we're going to do in our homework. Right? And we see our W shape, and we see it rises on the left and rises on the right. Okay? But what we're going to do here is we're going to find any local maximums or minimums. And so for those of you at home, this comes up here, down, and you should get a W shape. And we're looking for the lowest points, the local minimums. So we'll go to our trace feature, and we'll trace down to the lowest point on the left. And that lowest point is your local minimum, which is, I'm looking for the y value, which is negative 3.2. That's my local minimum. Do we have another local minimum? I do, because another local minimum is negative 3.1. So we have two local minimums. Okay, we try to get as close as we can.
Should be one more.
No, there's just two minimums.
Mine says negative 3.25.
Does it really?
I think it should go lower. Right there.
Right there, yes. So it's negative 3.2. You're right. Okay, so those are the two local minimums. And both of these occur here at negative 3.2. We're just looking at the y values. We have one local max. Do you see why they call it a local max? Because look, can we get the maximum of that entire function? No, because it goes up forever, doesn't it? But we have a local max, and that occurs at 3. So we have a local max where y equals 3. One local maximum, two local minima. Minima. That's plural of minimum. Okay? So that's how you find local max, local min. The next example I want to give you, and you can follow along in your book, because I'm going to do problem number 25. This one's a little bit different, even though I'm going to have the same type of drawing. F of x equals x to the 4th minus 3x cubed plus 3x plus 3. Now it says find all local max between negative 2 and 5. You can pretty much ignore those directions. So we'll go to our calculators and we'll put in y is equal to x to the 4th minus 3x cubed plus 3x plus 3. My calculator already is in a standard window. And when you graph it, and I'll just give a sketch. Comes down like this, up, down a little bit, and then up. And so that's what it should look like on your calculator. Let's use our trace function to find minima. It looks like there's two of them. I'll go to my trace. I guess we could say, let's say that we have a local minimum at, would you say 2? And I'm going to write 2.0 because it does say we're going to round to the nearest tenth. So that 1.98 rounds to 2.0. And let's trace over to the other local minimum, which is 1.0. So we have a local minimum here at this point, which is at 2.0. And we have a local minimum here at, I do that a little bit farther down, but this would actually be at 1.0. And we have one local max, and we'll trace up to the top. And that local max is at 4.3, and that's this area right here, 4.3. And that's our local max. All right. If you read the directions for 25, the directions say, graph each function. Find any local maximum or minimum to the nearest 10. We did that. Then find the intervals over which the function is increasing and decreasing. Now we're going to look at the x values. Okay, so let's go back to our first local minimum here and look at the x value. The x value at the first local minimum is -4, and let's say -0.4. Okay, and it's too bad we can't pick this up on the board, but when x is less than -0.4, this function is decreasing. For all values where x is less than -0.4, that function is decreasing. This function is decreasing when x is less than -0.4. We're looking at the x values. And I suppose we can do this. From negative infinity for the x to -0.4, this function is decreasing. Okay? Yes?
You know the arrow is pointing up?
Yeah, because you know why? Even though the arrow's pointing up, because we're reading from left to right. Okay, and that's the confusing part here. We read from left to right. And then reading from left to right, from this area up to the top, it is increasing. When x is between -0.4 and 0.6, when x is between -0.4 and 0.6, this function is increasing, right? And then when x is between 0.6 and 2.1, when x is between 0.6 and 2.1, we are decreasing again, and that's from here to here. And then when x is greater than 2.1, this function is increasing. Okay, so we're sort of tracing where the function decreases. It decreases to this point. It decreases to this point. Then it increases. Then it starts to decrease. Then it increases. And we're looking at the x values for increasing and decreasing. We're looking at the y values for the minimums and maximums. And then we're describing the end behaviors. That's what this lesson is about. It's a little bit confusing. You may want to read over the section. It should help you a little bit. Okay, I found the section, I read it this morning. I found it a little bit confusing, but it may help you a little bit. All right, so your homework for today. It's on page 438. I want you to do 10 through 28, the evens, and 29 through 43, the odd problems. Okay?